Hello, I am Professor Kalpesh Patel, Electrical Engineering Department from the Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Our subject is Bioelectronics of the B third year 5th sem and the subject code is 3140915. Our second chapter name is DC to DC converter, switching voltage regulators. So in previous lecture, we completed the topics up to the buck-boost converter. So in this lecture, we will conduct the various control techniques for output voltage control in DC to DC converter. So the chopper control strategies. A basic DC to DC converter shown in figure. Here transistor T1 or any bioelectronic switches. This is the freewheeling diode and this is the load. This is IO output current, Vs input voltage, VO output voltage. Here T1 is the SCI, like a static switch. Static switch, that means no moving parts. So all the bioelectronic switches are known as the static switch. The SCR can be turned on and turned off with the help of triggering circuit or a commutation circuit respectively. That means turned on by the triggering circuit and turned off by the commutating circuits. So if we consider T on and T off are the on time and off time of the chopper, so the duty ratio is given by the duty cycle D equal to T on time divided by T, where T is the total time. T on plus T off. So duty cycle is defined as the T on by T. As we all know, the load voltage of chopper is given by VL equal to VDC into T on by T, where VL is the load voltage and VDC is the input voltage and T on by T is the duty cycle. So we can change the output voltage or load voltage VL by changing the duty cycle, because if we consider the V input voltage is constant, so by changing this duty cycle we can change the load voltage. So from this above equation it is clear that to change the load depend on two factors. One is the supply voltage Vs, that is here is indicated as the VDC, and by changing the duty cycle of the chopper it is D. So by changing either the supply voltage or by either changing the duty cycle we can change the output voltage of the chopper. Since the supply voltage is constant, the load voltage is governed by the duty cycle of the chopper. The input voltage VDC is kept constant, so by changing the duty cycle we can change the output voltage. So in other words we can say that the load voltages depend on the two factors, T on time and T off time. So the average load voltage can be controlled by varying the value of T on and T off in the following two ways. First one is the time ratio controls. In time ratio controls, by varying T on time and keeping the time period T constant. So this is called the constant frequency system, because here total time T is constant. So by changing the T on time we can change the duty ratio, and this method is known as the constant frequency method. And second method is either keeping turn on constant, that means on time is constant but by varying the T of time, or by keeping the T of constant and varying T on time. So this is called as the variable frequency systems. So total time change in this system, so this is known as the variable frequency systems. So the summary is, in chopper circuit the average value of the output voltage VO can be controlled by opening and closing the semiconductor switches periodically. So the various control strategies for varying the duty cycle are follow. First one is a constant frequency system and second one is a variable frequency systems. Constant frequency systems in which we have to change the on time or off time. So this is known as the pulse width modulations, in which the width of the pulse will be changed. In variable frequency systems, it is known as the frequency modulation system. That means either t on time or t off time are kept constants, but the frequency will be changed. So this is known as the frequency modulations. So constant frequency system, so in which we have to maintain the total time t is constants. So first consider this is time t and this is width of the t on time and this is the width of t of time. So uh, if you want to change the output voltage, we have to change either t on time or a t of time, but we have to keep the total time t is constant. So here t is some value and there t is total time t on plus t off. Here t total time t on plus t off, but the total time t is same, but in constant frequency system t on time is change. Here t on time width is less compared to this and t of time is higher in this system compared to this system. So by changing the t on time and t of time, we can change the pulse width. So by changing the pulse width, we can change the duty cycle, and by changing the duty cycle, we can change the output voltage. And this system is known as the constant frequency systems. So it is also referred as time ratio controls. And in this scheme, t on is varied, but the chopping period t is kept constant, so we can maintain the constant frequency. Variation of t on means adjustment of the pulse width. So this method is also known as the pulse width modulation schemes. Disadvantages of the constant frequency techniques. The limitation of the pulse width modulation scheme is given by, in this technique, t on cannot be reduced to near the zero for most of the combustion circuit used in chopper. So we can in constant frequency we can change the t on time, but t on cannot be reduced to zero or nearer to zero. So this is the disadvantage of the constant frequency techniques. And one another disadvantage of the constant frequency techniques is, as such a low range of the control is not possible in PWM. So in PWM techniques, very low range of the pulse width is not possible. So this can be achieved by increasing the chopping period or decreasing the chopping frequency of the chopper. So this system is known as the variable frequency system. In variable frequency systems overcome the drawback of the constant frequency systems. So in these schemes, the chopping period t is varied either by keeping the t on time constant or either by keeping the t of time constant. So this method of control duty cycle is also called the frequency modulation schemes. Variable frequency systems. Consider the case 1. Here two case. Case 1 is the kept the constant t, but by varying the t on is kept constant, but by varying t. So this is first case. In second case, t off is kept constant and vary the t on. So in both the cases, total time t will remain same. Variable. So t, first consider t on is the 1/4 of the total time. So here total time is t and t on is the 1/4 portion of this total time. So duty cycle d is t on by t. It is the 25%. In next figure, t on time is kept constant, but t is varied. So t on time is 3/4 portion of the total times. So duty cycle is the 75%. So in this two cases, T on time is kept constant, but total time T is changed by changing the T off time. So we can change the duty cycles. So in first case it is 25%, so we get the lesser output voltage compared to second case in which the duty cycle is the 75%. So in this case we get the 25% of the input voltage at the output side. In this case we get the 75% of the input voltage at the output side. Now second case, T off is kept constant. So that means in both the cases T off we have to maintain constant. So by changing the T on time we can change the frequency. First consider the T on time is the 1/4 portion of the duty cycles. So this is T on time and this is the total time, but this portion is the 1/4 portion of the total time and the remaining portion is the T off time. So by equation of duty cycle is the T on by total time, but T on is the 1/4 portion. So here we get 25% of the duty cycles. In second case, consider the T of time is kept constant. So this T of and this T of is same, but by changing the T on time we can change the total time T. So by changing the total time we can change the frequency. So here T on time is 3/4% of the total time. So the duty cycle is 3/4% of T divided by T. T will cancel out and 3/4 equal to the 0.75. So in this case the duty cycle is the 75%. So in this case we get the lower output voltage compared to this voltage. In this situation we get the 25% of the input voltage at the output side. In this situation we get the 75% of the input voltage at the output side. So we can change the output voltage in chopper by two methods. One is a fixed frequency method and one is a variable frequency method. Disadvantages of the variable frequency techniques. The chopping frequency has to be varied over the wide range of the control of the output voltage in frequency modulations. So in variable frequency techniques we have to change the wide range of the frequency to control the output voltage. So filter design is such a wide frequency is very difficult. For the control of frequency variation would be wide. So if the variation is very wide, so it is possible to interfere with the other communication techniques nearer to the chopper. So other communication techniques like signaling and telephone line, which is the this system will add the noise in nearer communication system. In variable frequency systems, the large T of time in frequency modulation scheme may take the load current discontinuous. So if we take the large T of time, so load current become discontinuous. Discontinuous, that means it becomes zero. So it is the undesirable. Now the last one method of the control the output voltage is the current limit controls. As is obvious for its name, current limit control. In this control strategy, the specific limit is applied on the current variations. So in current limit control, we have to set the two limits of the current. First one is the minimum current and second one is the output current. Minimum current and maximum current. So by changing the average value of the current, we can change the load voltage of the output side. So if we set one minimum current, which is the I minimum, and maximum limit I maximum. So the switch is turned on when the current reach at minimum value. So now at this instant, if we turn on the switch, the current through the load is linearly increased and reach at this maximum limit, the switch will be turned off. So now the current is decreasing from linearly from peak value. As the current reach at this minimum value, once again the switch will turn on and rise linearly. And when current is reached at peak value, the switch will be turned off by the control circuit. So by setting the minimum value of current and maximum value of current, we can change the on time and off time. If we set the maximum value lower than this, so if we set maximum value at this point, so the switch will turn off at this point. So we get the pulse width is only these portions, and this portion will, and current now from this point linear decrease, and this portion will remain as a turn off time. Further, this current reach at this value, at this portion switch is again turns on and remain turned on for its maximum value. When current reach at this value, the switch will turn off and remain closed. So by changing the maximum and minimum value of the current, you can change the duty cycles. If we increase the maximum current limit, which will increase the turn on time, and this is turn off time. So by changing the minimum and maximum value of the current, we can change the duty cycle of the switch. So we can change the output voltage. So in this method, current is allowed to fluctuate or change only between two values. One is the maximum current value and one is the minimum current value. When the current is minimum value, the chopper is turned on. After this instant, the current start increasing, and when reached to its maximum value, the chopper switch is turned off. So the current fall back to its minimum value, and this cycle will continue again and again. Now the G2 questions. First one is the how do you control the output voltage of the chopper, and list the methods. So in which you have to explain the duty cycle and explain the equation of the output voltage with respect to the duty cycles, and list the different method based on these equations. So this question will be asked in your G2 examination for the 3 marks. Second one is explain the brief various control strategy of the choppers. This question will be asked for a 7 mark, so you have to explain in brief all the techniques, time ratio control and frequency ratio controls. And last one is what is the current limit control for the chopper, and explain in brief. So in this we have to explain the current limit controls by setting the value of minimum current and maximum current. So this is not a big topic, so this will be asked for a 3 marks in your GTU examinations. So we completed the all the topics up to the various control techniques of the output control. So in next lecture we will conduct the closed loop control of the voltage regulation, because the concept of CCM, that means continuous conduction mode and discontinuous conduction mode of the chopper, which is already covered with the different types of converter, buck converter, boost converter and boost converter with the continuous conduction mode and discontinuous conduction mode. So this topic is covered with the different types of the converters. So in next lecture we will conduct the closed loop control for the voltage regulations. Thank you.